Hello everyone, this is Vasant, a nine-pointer at IIT Bombay from the Department of Civil Engineering. In this video, we are going to solve a problem on built-up beams to understand the concepts clearly. So this is the problem. You see, there is a wooden built-up box beam is shown over here. A allowable shear force in each nail is 800 newtons. Okay, so they can resist the shear force of 800 newtons, that is maximum. After that it will fail, see, if we take a nail and here it is acting the shear force, then after failure it will become like this, right? That is of shear failure in bolts or nails. Okay, so find permissible nail spacing for applied shear force V is equals to 10.5 kilonewtons. So we know that first we need to find out the neutral axis. So that neutral axis will be at centroid. So this is the neutral axis, right? And we need to find out the Q. For that, first we need to fix this niche ka portion. Fix this and then push that. Then which portion will maybe about to shear off? That will be this portion, right? This portion. So consider that portion for calculating Q. So Q for that portion, Q will be is equals to area of that portion. That is, if you see, that is of 120 is here. Okay, this is of 280. So this is of 40, means this is also of 40. Okay, so 40 and this length is 180. It is 180, right? Yes. So 180 into 40 is the area into centroid ka distance from neutral axis. So that centroid will present over here. So this will be 20, right? And this is, sorry, this is already given as 120. So this is 120 mm3, right? And what is the thick? We know we don't need thickness, right? Because Q total will be is equals to VQ by I. Okay, so this is Q, and what is V? V is given as 10.5 into 10 cube Newton. That is applied one, and we need to find out I of the whole section. Okay, so we can say one, this one as this one minus this one. So this distance is 180 plus 30, that is 210, right? And this will be of 280 because 40 plus 180 plus 40. This is 40. Sorry, this is already given as 280. This one. So this is 280. So minus this. This one is minus, right? So this will be of, this is of 180, right? So 180. And this will be of, you see over here. So 280 minus 40 and minus 40. So that will be 200. So about the I is about neutral axis. Same neutral axis will present over here. Same neutral axis will present over here. Okay. So we get I for this will be is equals to I for this, that is 1 by 12 into B is 210 into 280 whole cube, minus I for this, that is 1 by 12 into 180 into 200 whole cube mm power 4. To calculate this, we get 262 into, sorry, 264.2 into 10 power 6 Newton per, sorry, mm power 4, right? This is I. And if you calculate the value of Q, that will be 864,000 mm cube. So Q total See, Q total will be V, that is 10.5 into 10 cube, into Q, that is 864,000 mm cube, divided by 264.2 into 10 power 6 power 4, right? So if we calculate this, we get Q total as 34.3 Newton per mm. But Q total is equals to, because there are two holes, that is 2 Q each. They are symmetric, so that will be Q each. So Q each will be is equals to 34.3 by 2, right? Newton per mm. See, so we got Q each. So Q in this section we got, and Q in this plane we got. So for each bolt, if they are placed at equal spacing, so we said that shear strength of the bolt should be is equals to Q each into S. So maximum shear strength it can sustain is 800. So Q each is 34.3 divided by 2 into S. So this will be maximum pacing that we can provide. उससे ज़्यादा provide नहीं कर सकते. So S max will be is equals to 1600 divided by 34.3. So we get as 46.6 mm. Okay. So before ending this lecture, I want to discuss one more thing. See, actually, when there is a beam, because of the loading on the beam, generally the shear stress will vary at every cross section, right? Means at every cross section, the value of Q each vary, right? So for every cross section, the S max will actually be different, right? But why we generally calculate for V max case? So minimum S, the maximum minimum S means, see, we have S max for at every cross section, right? So in that S maxes, we take the minimum S max and we will put that one. Okay. Why we are doing like that? So we can provide by taking these things if we need to provide correctly, right? Because that will be tedious, right? Calculating at every section is somewhat tedious. Then calculating the minimum spacing that we need, maximum permissible spacing for the maximum shear force. So we will provide for that spacing because that will be more safer than this one, right? That will be more safer, and that will be easier to the carpenter to provide that nails, right? So he need to provide at equal distance overall beam, so that will be easier, right? Comparing to changing that as frequent along the length. So that is the reason why we generally calculate for maximum shear. For maximum shear, we will get some value of maximum spacing that can provide for that shear. Okay. But that will be the minimum of all maximums of all shears that existed in the beam. Okay, that you need to understand. So I hope you understood this concept clearly. If you like this lecture, do subscribe to our channel, Ninepointer. Thank you.